everybody. So today we're doing 5 exponential models. Okay, so a special exponential growth formula or compounding interest. The equation is a sub t or a to t equals p parentheses 1 plus r divided by n to the t-nth. We did this at the end of last video, or the end of the last video. So P is your principal, or your starting amount. R is the rate, or the annual interest, written as a decimal. N is the number of times the interest is applied during the year, so compounding periods per year, so like 12 or 4. And then A to T, or A parenthesis T, equals the value of the account after T years, and T is the number of years. Okay, so different types of compounding periods. We have $3,000 we have a $3,000 investment with a 12% interest rate where interest is applied differently. So the very first time is annually. Thinking about this, annually, the number of times in a year. So annually just means, hey, A is just 1, or N is 1, sorry. So 1. My formula is going to be A of T equals 3,000 parentheses 1 plus 0.12 divided by 1 to the t times 1. So after 3 years, we're going to do 3,000 1 plus 0.12 divided by 1 to the 3 times 1. You can plug this into Desmos. It'll make it way easier for you. If you do, you should get 4214.78. Okay, so let's go ahead and try the second one. Semi-annually or semi-annually. Number of times per year, that one is 2 times per year. So again, my formula, I have A of T equals 3,000 times 1 plus 0.12 divided by 2 times T times 2. So 3,000, parentheses 1 plus 0.12 divided by 2 times, this time we're going to have 3 times 2. So when we plug that in online, we should get 4255.56. Okay, quarterly. How many times is quarterly? That is 4 times. So again, we have A T equals 3,000 times 1 plus 0.12 divided by 4 this time to the t to the 4th, or t times 4. So again, just copying this down again, 3,000, 1 plus 0.12 over 4 times 3 times 4, which is 12. When you plug that in, you should get 4277.28. That doesn't look like a 4. 4. Okay. Next one, monthly. How many months are there in a year? There are 12 of them. Okay, so over here we have A times T equals 3,000, 1 plus 0.12 divided by 12 times T times 12. So we have 3,000, 1 plus 0.12 divided by 12 times 3 times 12, which gives you 4292.31. Okay, weekly, very last one. How many weeks are in a year? 52. So just like before, A T equals 3,000 times 1 plus 0.12 divided by 52 times T times 52. So that gives me 3,000 times 1 plus 0.12 divided by 52 times 3 times 52, which equals 4298.21. So if you notice here, None of your answers are the same exact thing. This is just like what I was talking about on that last video. As it goes further and further, like more, like so 52 is bigger than 1 or bigger than 2, that shows, hey, it's increasing faster than what it would be normally. Okay, so that even shows it right here. It shows, hey, you can plug in all of these, and if you look, the one that is at 52 is the one that goes up the steepest, like it goes the fastest. At the beginning, they're pretty close together, but then as it keeps going, it just goes out further and further. They're just spreading out further. Okay, so let's go ahead and look at this next question. So we have $30,000 is invested in an account that earns 4% annual interest, compounded monthly. What is the value of the account after 10 years? Okay, so we're starting off with 30,000 times 1 plus, we have annual interest, so 0.04 divided by, it's compounded monthly, so what number is that? That's divided by 12. And then we're looking at 10 years, right? So I have 10 times 12. When you plug that in, that will give you 44724.98. Okay, so what is the value after 100 years? Again, we have 30,000 times 1 plus 0.04 divided by 12. 100 times 12, which is going to give us $1,627,085.23. Okay, how much more money do you earn by compounding the interest monthly than quarterly over a 5-year period? Okay, so, is it? Yeah, quarterly. Okay, so let's go ahead and try this out. We have one. Let's go ahead and do monthly first. So for monthly, we have 30,000 times 1 plus 0.04 divided by 12. And then we're looking at 5 years, right? So when we plug that in, that's going to give us 36629.90. Now let's look at it quarterly. So quarterly, that's 30,000 times 1 plus 0.04 divided by quarterly. How many quarters? So that's 4. 5 times 4. That's going to give us 36605.70. So now we're just going to subtract these two. So we have 36629.90 minus 36605.70. So that tells us that we are earning, if we do it monthly, we are earning $24.20 more after 5 years. Okay, so looking at this next one, a special type of time period, continuously compounding. Okay, so continuously compounding means, hey, it's compounding for every second. So sometimes interest is compounded continuously. This means every second of every day you are either earning if it's investment or if it is an investment or owing money. When you read the phrase interest compounded continuously, you should use A of t equals P times E to the RT. So what is E? E is the natural base. It is an irrational number. So it's kind of like pi. So like 3.14159, blah, 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 blah. It is just like that. It's just a longer version of it. It is approximately 2.7183 and then some other stuff. It is a constant, not a variable. So do not ever solve for E. E is a constant. It is just like pi. So A of t is, again, the total amount of money in the account after t years. P is my initial investment. R is my annual interest rate written as a decimal. E is the natural base, or it is a constant. So if you want on the side, write constant. It does not change. T is my time, and the variable t of time in this formula, the value of the investment, varies on how long the money is invested for. Okay, so Vanessa invests $26,500 in an account that earns 9.2 annual interest, compounded continuously. What is the value of the account after 12 years? So we have 26,500 e to the, okay, so R is my rate, so 0.092, and my amount of years is 12. So that's going to tell me that it is 79929.48. So let's take a look over here. Does that look about right? So we're at 12 years, so a little bit past there. Yeah, that's above the 70, so that looks good. Perfect. Okay, so that was the main big thing for this. Was I just wanted to show you, hey, here's how you compound your interest, so you want to see things. If they are telling you that, hey, it's this much interest and you can pay it monthly or things like that, that compounds over time, okay? So we are done. Don't forget to do your Delta math, and feel free to send me any questions that you may have. Have a good rest of your day.